Okay. So very good morning to all of you. I hope that everyone is able to see the screen. If you are not able, please give a reply in a chat box. Are you able to see the screen? Okay, Hina. Okay, so we will start. So in the last lecture, we have discussed about the three-phase system. Okay, so okay, so we have discussed about the polyphase circuit. Okay, it is also known as three-phase circuit. Okay, now the phi is symbol of phase. Remember this thing. Okay, phi is a symbol of phase. Okay, so in the last session already we have started this and we have discussed the three terminology. First of all, we have discussed what is a phase sequence. Okay, the definitions we have learned. Okay, which definitions we have learned? Okay, so first of all is the phase sequence. Okay, second definition was the line voltage. Third one, it is a phase voltage. Fourth one, it is a line current. And the fifth one, it is a phase current. Okay, so in the last session, we have discussed about this definition. And we have discussed that in three-phase system, there are two type of connections are possible. In three-phase system, connections are two type. One is called as a star connection and other is called as a delta connection. Yes. Okay. Now in a star connection, it is look like this. Okay. And the delta is look like this. Okay. So three phases are there. If you are connecting the three phases in a such a manner, it is called as a star connection. If you are connecting this fashion, it is called as a delta connection. Okay. Now we are going to derive the relationship between line voltage and phase voltage in case of star connection. Okay. So that is the theory which is very important. Okay. So now give your full concentration over here. What is the theory? Derive the relationship between line voltage and phase voltage, line current and phase current. Already you have done this theory in a practical. You have proved this in a laboratory sessions also. Derive the relationship between line voltage and phase voltage, line current and phase current in case of star connection. In case of three-phase star connection. Three-phase star connection. Okay, so how you can do this theory? So let us we will start with the star connection. It is very easy, but it is very important. Okay, so first of all, I will draw a three phases in a star. Okay, so consider that I have a star. Okay, I have a one star connection. And here what is? Here the winding is there because we are generating the voltage by using a winding. Okay, so consider that here three windings are there. Okay, now consider this is your R phase. Okay, as I told you, there are three phases R, Y, and B. Okay, so here I will give a name. 1 minute, there is an issue in a pen. One minute, there is some issue with the pen. 1 minute. One minute. Actually, please let it. Not working. One minute. I am reopen this OneNote. It is not working. That's why. Please bear 1 minute. The laptop is hanged. That's why 1 minute. Here the drawer and view is not visible. Okay, so now it is okay. So thank you for just a second. So now we will start. Okay, so here we want to derive the relationship between line voltage, line current and phase current in case of a three-phase star connection. So consider that I have a R phase Okay, so that is a R terminal. Okay, you can see it is a R dash. Okay, so it is a one phase. It's starting, it's ending of one. Consider the second phase. It is a Y, and here there is a Y dash. Okay, I will use a green color for this. Say for example, it is Y. Okay, and it is a Y dash. Now B phase. So consider that is your B terminal, starting of B phase and ending of B phase. Okay. So what we have done for star connection, all the ending terminals R dash, Y dash, B phase, B dash are connected together. Okay. And that's why it is make a one neutral point. Okay. So here there is a three phases we have connected. Now I will take a one line from this R. Okay, the another from the Y. Okay, and third one from the B. Okay, so here we have taken the three lines from this R, Y, and B. So that's why it is called as a R. Okay, it is called as a Y terminal. Okay, and that is called as our B terminal, R, Y, B. Okay. Now, as I told you, what is the definition of line voltage? So voltage between any two phases, that is called as a line voltage. So here I can say this is my R and this is my Y. Yes or no? It is a R. Okay, see this terminal, it is connected with a R, and this particular point, it is connected with Y. Okay, so this arrow, I have connected between R phase and the Y phase. Okay, so that's why it is called as a VRY voltage between R phase and Y phase. Okay, so here I'm writing this voltage is VRY. Okay. Okay, all of you are able to see the screen. Please give a reply because before few minutes we have an issue. That's why. Is it okay with? Okay, so VRY, so it is a line voltage between R phase and Y phase. Remember, the definition of line voltage is what? Voltage between any two phases. It is a line voltage. So R and Y, it is a R Y phase. Okay, now same way here, I can say this is the Y and B phase. Okay, so here I can write RYYB. Okay, and now the third one is BR. Okay, because why BR? Because see, our what is our phase sequence? Our phase sequence is R, Y, B. So the combination is first of all RY, then YB, and then BR. Okay, that's why. So the third voltage is VBR, voltage between B phase and R phase. Okay, so these all are known as a line voltages. Okay, now here we are assuming that our system is balanced. Okay, our consider our system is balanced. Okay, now what is the meaning of system is balanced? It means whatever the number of turns here in a R phase in a winding, the same number of turns in the winding of Y phase, the same number of turns of winding in a B phase. Okay, and the material is also same. Okay, so material is also same, number of turns also same, and they are rotating in a same magnetic field. Okay, So whatever the voltage produced by all these phases will be remain same. Okay, so that is called as a balance system. That is called as a balance system. Okay, so consider that our system is balanced. So we can say V R Y, voltage produced by R and Y, voltage produced between Y and B phase, and voltage produced between VBR are same, and they all are known as a VL. Okay, what is a VL? VL is equal to line voltage. Clear? Okay, so instead of RY, you can write VRY, YB, and BR. Okay, so that is our line voltage. Now, what is a phase voltage? So see over here. What is the VBR? Just a second, I will just check VBR. Oh, sorry. Yes. It is a voltage between B and R phase. Sorry. Okay, here there is a mistake. It is a VBR, voltage between R phase and R phase. Thank you for just okay, that is our okay, now it is correct. Okay, and we will make a one jumper here, means there is the red and blue and red line are not connected. Is it clear? Okay, so now see the figure again. RY, R and Y voltage, YB between Y and B phase, BAR between B and R phase. Okay, so that is our line voltage. Now, what is the meaning of phase voltage? So see here, we have our neutral point. Yes or no? See my green circle. Okay, so what is the neutral? Because here we have connected all the phases together. R dash, Y dash, B dash are connected together and it will make a neutral. Okay, so now what I will do? I will take a one line from the neutral. So consider that I'm taking a one line from the neutral here. Okay, and that is your neutral. So what is the definition of a phase voltage? So voltage between any one phase and neutral, that is your phase voltage. Okay, so consider here, I will draw one line. Just a second. Okay, so consider that I have drawn this one line. Now this line is drawn between which and which? This red arrow is drawn between the R phase and neutral. So that's why it is called as a neutral voltage. Okay, VRN. Same way I will draw another line between Y and B phase. Okay, so consider that there is another line I will draw between Y and neutral. Okay, and B and neutral. Understand? Okay, so here this voltage is known as a VYN, voltage between Y phase and neutral, and this voltage is known as a VBN, voltage between B phase and neutral. Is it clear? So what is the definition of we can say phase voltage and line voltage? Is it clear? Write down in the chat box. Okay. So we have drawn. Now, as I told you, our system is balanced. Okay, so I can also say that as the system is balanced, our phase voltage is, okay, what is our phase voltage? VRN, okay, VYN and VBN, all are same. Why? Because the system is balanced, and that is called as a phase voltage PH. The PH suffix is a two starting word letters of the phase. Okay, and that is nothing, it is called as a phase voltage. Okay, now let us, we will draw the line current. Okay, so which is the line current? So see that is our line number 1. Okay, this is nothing, it is our line number 1. Can I say? Okay, Y it is our line number 2. Okay, and B is nothing, it is our line number 3. Yes or no? Okay, so the current here is passing. I will give a name. It is a line current IL1. Okay, because it is passing through the line number 1. This is our line number 3. So I will give a name, sorry, IL2, line number 2. See, this is our line number 2. Okay. And here, whatever the current is passing, that is our line number 3. So I will give a name IL3. Is it clear? Okay. So IL1 is equal to IL2 is equal to IL3. Why? Because our system is balanced. Okay. So that is the line current. Okay. Now, what is a phase current? So current passing through the phase, it is a phase current. So see, this is our system that is rotating in a magnetic field, and that's why it is producing a three-phase voltage. So the current is coming from here and it is coming out from the phase. So that is a phase voltage IR. Okay, understand, the current coming out from the phase, that is a phase current. It is our phase current IY. Okay, and that is our phase current coming out, that is a IB. Okay, so IR, IY and IB are our phase current. IL1, IL2 and IL3, that are our line current. But as I told you, our system is balanced. So here I can write the line current IL1 is equal to line current IL2 is equal to line current IL3 is equal to IL. Okay, what is IL? Line current. Okay, same way, what is the IR? So IR is a phase current of R phase. IY, it is a phase current of Y phase. And IB, it is a phase current of B phase. Okay, and that is called as a IPH. Okay, phase current. Okay. So here, from the figure, what is a relationship between, understand, see the arrow. What is the relationship between this IR and IL1? What you can see? See, the IR is coming from here. Okay, and IL1 is this. What you can say about IR and IL1? Yes, Krishika, it is equal. Can I say IR is equal to IL1? From the figure, can I say IR is equal to IL1? All of you others, write down your answer in the chat box. Same way here, see the arrow of IY. So can I say IY and IL2 are same? Yes, Jay. IY is equal to IL2. Same way I can say IB and IL3. See, this is my IB and this is my IL3. So can I say IB is equal to IL3? Yes or no? Okay, Fiza. Okay. So here I can say from the figure, IR is equal to IL1. Okay. So from the figure, I can say, so here you have to write down. Okay. From the figure, okay, IL1 is equal to IR, IL2 is equal to IY, IL3 is equal to IB. Okay. Now tell me, what is the IL1, IL2 and IL3 is equal to what you can write? IL1 is equal to, see this one. IL1 is equal to IL2 is equal to IL3 is equal to line current. Yes or no? One minute, the Zoom is making some error. Okay, now are you able to see the page? One note page, please give a reply. Okay. So what I can say, IL1 is equal to IL2 is equal to IL3. So can I write this equal to IPH? Yes or no? Sorry, this is IL. Can I write yes or no from this particular thing? Okay. Same way, here IR, IY and IB. So what is IR? It is a phase current. IY is a phase current. IB is phase current. Okay. So from this, we can say IR is equal to IY is equal to IB is equal to phase current. Okay. So can I write here? Okay. So here I can write it is IPH. Okay. Yes. So what we have established the relationship. Okay. We have established that from this figure, the IL is equal to IPH. IL is equal to IPH. Okay, so this one thing we have proved that in a star connection, IL is equal to IPH. Okay, but now what about the voltages? Okay, so here see, VRY is nothing, it is a line voltage, and VRN is equal to what? It is a phase voltage. But here you can see the VRY is the voltage between point here A and point here B. Yes or no? And the VRN, it is a voltage between this A point and here the point is, say, for example, C. Okay, so from the diagram, we can't say that VRY is equal to VRN. Can I say VRY is equal to this VRN? Can we say? No. Okay, why? Because both are at a different terminals. Okay, so now we have to establish the relationship between line voltage and phase voltage. Okay, so for that, we have to draw the phasor diagram. So how we can start this phasor diagram? Okay, so first of all, we will draw the three phase voltages. And we know that the voltages are apart from each other by how much degree? The voltages are apart from each other by how much degree? 120. Yes, very good. Okay, so they are apart from 120 degree. Okay, so let us, I will draw first of all I will draw the three phase voltages which are 120 degree apart from each other. Okay, now consider that this is our VRN. Okay, so at a 120 degree, this is my VYN. Okay, and at a, again 120 degree, there is my VBN. Okay, and also between the VB and VRY, there is a 120 degree. Yes or no? Okay, so what is the first step to draw the phasor diagram? Draw the phase voltages 120 degree apart from each other. Okay, now what is I required? I required a relationship between VRY and VRN. Are you getting my point? Okay, so what we have done? First of all, we have drawn the phase current, phase voltages. Now I draw the phase current. Now see, our winding is which type? Our winding is resistive or inductive? Write down your chat box in a chat box. Our winding, it is a resistive or it is called as a inductive? It is a inductive. Okay, and always I told you that inductor is not a pure, it is a combination of RL. Okay, so here consider that our winding is look like this. Okay, it is a RL type load. It is a RL. Why? Because each winding have a some internal resistance. Okay, so it is one type of RL. So can anybody tell me in a RL circuit, the current is leading or lagging by voltage? In RL type of circuit, the current is lagging or leading? Write down your answer in a chat box. Yeah, Preet, it is the leading. Yes, V leads. That is correct. Okay, voltage is lead by the current. Okay, see that in a RL circuit, the current is lagging. Refer the RLC circuit. RL and RC. Okay, refer the RL circuit. The current is lagging. Yes or no? Okay, already I have posted this in a WhatsApp group. Refer that. Okay, current is lagging. Current is lagging by how much degree? By some angle phi. Okay, it is not exactly 90 degree. It is not exactly 0 degree. Why? Because if it is purely resistive, then the phi is 0. And if it is purely inductive, then this phi is a 90. But it is between that. Okay, so consider that here, this is nothing but it is the RL. Okay, this is winding is RL type. Okay, so here if I want to draw the current, so I have to draw current which is at a 5 degree from the VRN. So what I will do, I will draw current. Okay, that is my IR phase current. Okay, because see, it is your phase voltage. So with respect to the phase voltage, you can draw phase current, and IR is our phase current. Okay, and consider that this is at a 5 degree by some angle phi. Okay, by this angle is phi. Okay, now as I told you, our system is identical. So whatever the angle between VRN and IR, the same angle is between here VYN and IY. Okay, IY is my phase current. Okay, so that is my IY, and this angle is also phi. Okay, consider the same. The third current is IB. Okay, so that is my IB, and the angle it is also phi because our system is identical. So the angle between voltage and current is for all the phases will be remain same. Is it clear up to this? Yes or no? What I have done, first of all, I have drawn the phase voltages 120 degree apart from each other. After that, I have drawn the phase current which are lagging by respective voltage by some angle phi. Okay. Now our task is what? Our task is to draw the VRY, line voltage. In this diagram, I want to draw the VRY. Now see the figure. See this figure. What is a VRY? Understand? No? What is the VRY? I want to find out this. So can I say the VRY is the voltage between here to here and here to here? Yes or no? Yes or no? Consider this is my A terminal, A point. This is my B point, and this is my C point. Yes or no? Okay. So what is the, so it is A terminal, it is a B point, it is a C point. Understand? Okay. So it is nothing, it is a VRN. Yes or no? Voltage A is connected with a R and B is connected with a neutral. Okay, so that is VRN. And what is this? Here there is a neutral and here there is a Y. So here I can say it is a V and Y. Yes or no? Because to go for R to Y, I'm going from R to N and then N to Y. So I'm getting a VRY. Is it clear? So here I can write VRY is equal to VRN plus VNY. Getting or not my point? From here to here and from here to here. A to B plus B to C. Yes or no? Write down in a chat box. VRY. Okay. Okay. So VRY is equal to, I can say VRN A to B plus B to C, that is V and Y. Okay. And it is a phasor summation. Okay, so here I will remove this because the diagram must be neat and clean. Okay, so just for understanding, I have put ABC point. Okay, So I just remove this. Okay. So now I'm writing that we have confirmed that what is a VRY. Okay. So from the diagram, we can say VRY is equal to VRN plus VNY. Okay. So the same concept we are using here. Okay. We have seen that. Now I will remove this because you know this thing. Okay. About this inductor. Okay. So here I'm writing that as per our discussion, VRY is equal to VRN plus VNY. Okay, now see, these are the phasor. These are the phasor. So if I want to write down VNY is a VYN, so what should I have to do? Instead of writing NY, I want to write down YN. So what should I have to do? It is a phasor. Yes, very good, Krishika. You have to put a minus sign. Okay, say for example, I have a one phasor. Okay, and this is a V and Y, say for example. So if I want to draw VYN, then it is a opposite phasor. Okay, so that is my VYN, or I can say minus V and Y. Yes or no? Is it clear to all of you? So here I can write. So here I can write VRN, and here instead of plus I will put a minus, and it is now my VYN. Okay. So is it clear to all of you? Okay, so you know that if you want to make it opposite, then you have to put a minus sign. Okay, now tell me, in the figure, are you able to see the VRN? In this figure, are you able to see the VRN? Yes or no? Yes. Okay, and in the figure, are you able to VYN? Yes or no? Yes. Okay, but this VYN, you require a which sign? Which type of VYN do you require? You require a minus VYN. Okay, so what you have to do, you have to take the opposite of this VYN. So now what I will do, I will draw opposite to this VYN. Understand carefully. Just a second, I will take another color. Okay, so that is what? It is my minus VYN. Can I say yes or no? Please give a reply in the chat box. Okay, Jay. Okay, so now what is a VRY? Yes, so VRY is a phasor addition of VRN and minus VYN. VRY is a phasor addition of VRN and minus VYN. Okay, so now I will do the phasor addition. Okay. Okay, and to do the phasor addition, I will draw the parallel line of the VRN. So just to see over here, I will draw. Again, I'm repeating. What I'm going to do, I will draw a parallel line of a VRN. So just see over here at the end of the minus VYN. Okay. And now parallel line of a minus Vyn. Are you getting this? Okay, what is this? This is a parallel line of Vrn. Okay, and this is a parallel line of minus Vyn. Are you getting yes or no? Give a reply. Okay. Okay, thank you. Okay, now I will find out the resultant of this. So to find out the resultant, what I will do? I will draw a one line. I will draw a one line like this. Okay, so what is this third line? What is this? Is nothing. It is my VRY, yes or no? Because what is a VRY? VRY is a phasor addition of VRN and minus VYN. Getting? Okay. So now I will remove this line. Okay, it is just I have drawn for your reference. Okay. Okay. Now, what is the equation of VRN? Already you have studied. It is a parallelogram. Yes or no? So can I say that VRN, sorry, VRY means this one. Okay, what is this VRY that we want to discuss? So VRY is equal to under root of in a mode VRN square plus this equation you know, okay, minus VYN square plus 2 VRN VYN both the side, okay, and cos theta. What is the theta? Can anybody tell me? Theta is a angle between VRN and minus VYN. Yes. Okay. So what is the angle? So now we are interested in this angle. Yes or no? We are interested in this angle. So can anybody tell me what is this angle? Theta? It is a 60 degree. Yes, very good. Why? Because see this VYN and minus VYN. What is the angle between VYN minus VYN? Tell me, it is 180. Yes or no? This angle is 180. Okay. And this angle is 120 between VR and VYN. It is a 120. So 180 minus 120. So that is nothing. It is a 60 degree. Wait, sir. That is a theta is equal to 60 degree. Is there any confusion that theta is equal to 60 degree? Anyone? Is it clear how the theta is 60 degree? If anyone have a confusion, please give me in a comment in chat box. Okay. Okay. So theta is equal to 60 degree. Okay. It is clear. So now what I will write here? Now see, VRN is our VPH. RN is a phase voltage. VYN is a phase voltage. Okay. So now, and VRY is a line voltage. Okay. VRY is what? It is a line voltage. So I can say VL is equal to under root of VRY, it is our phase voltage. Please off the video. Okay, and that is also our VPH. VYN is also our VPH. VRN is again VPH. Minus VYN, it is also VYN is also VPH. Okay, and our cos theta is now it is a 60 degree. Okay. So what is the cos 60? So under root of VPH square, it is a 2 VPH square. Okay. And it is a 2 VPH square. What is the cos 60? Yes, cos 60 is equal to 1 by 2. Okay. So 2 VPH square and cos 60 is equal to 1 by 2. Cos 60 is 1 by 2 because cos 60 is equal to 1 by 2. Okay, so what is the answer? So here we can say 2 will be cut. This 2 and this 2 will be cut. Okay, so under root of 3 VPH square, 3 VPH square. Okay, so if I will remove the under root, so here is equal to under root 3 VPH. Okay, so that is our derivation, which is the give a relationship between line voltage and phase voltage in case of a star connection. Is it clear? So we have derived the relationship between line voltage and phase voltage. Okay, so how this theory will be asked? Already I told you. Okay, derive the relationship between line voltage and phase voltage means we have to VL and VPH. So we have derived this relationship that VL is equal to root 3 VPH. We have derived. Okay, and the another relationship is between line current and phase current. So we have derived that line current is equal to phase current. Okay. So I hope that this theory is clear to all of you. Yes or no? Okay, so if any doubt you can ask, otherwise you can write your enrollment number in a chat box quickly. Write down your enrollment number in a chat box. Okay, so I hope that everyone has written the enrollment number in a chat box. So here I'm ending the session. Thank you all of you. Om, write down your enrollment number. Om, write down your enrollment number in a chat box. Okay, thank you all of you. So here I'm close the meeting.